In this video, we're going to take a look at another example of solving polynomial equations by factoring. So in this equation, it says solve 15x to the power of 3 plus 50x squared plus 2 equals 5x squared plus 7x plus 23. So the first thing I notice is that I have more than one term with an x. We have x cubes, x squared, and then just x's, which means solving by rearranging is not a strategy that we can use here. Factoring is what this section is all about, but in order to solve by factoring, the first thing we need to do is make sure that all of the terms are on the same side and that one of the sides of the equation is 0. So in taking a look at this question, I would like to move all of the terms to one side, and I have a choice. I can either move them all to the left or I can move them all to the right. So how I make my decision is I take a look at the highest exponent. The highest exponent we currently have is a power of 3. If the coefficient of that is positive, I will leave it where it is. And if it's negative, then I would end up taking it to the other side. So I like the leading coefficient to be a positive value. It just works better when we're factoring. So I will try to rearrange it so that the term with the highest exponent has a positive coefficient. So since this is already positive, I am going to move the terms on the right-hand side over to the left-hand side. So I'm going to take 5x squared away from both sides. And I'm going to line it up with its like term partner over here, the 50x squared. I'm going to subtract 7x from both sides. Now I don't have a like term partner for that, so I'm just going to write it kind of in between the x squared and the constant. And then I'm going to subtract 23, and I'm going to subtract that from its like term partner, the 2. So we are going to end up with 15x cubed. 50 take away 5 is 45x squareds. I have the 7 minus 7x. And then 2 take away 23 is negative 21. And then on the other side, there are currently no terms left. So I'm going to say that it equals 0. And it is important for you to write that 0 in. You can't just turn an equation into a one-sided expression, right? We have to maintain what's on the other side. All right, from here, I now would like to factor. It is not currently factored. I can tell because this is not a multiplication question. So my goal is to see if we can turn this into at least 2 brackets being multiplied by each other. So I notice there are 1, 2, 3, 4 terms. And when I have 4 terms, the first thing we try to do is common factor. Now 15, 45, and 21 all divide by 3. Unfortunately, 7 does not. 15 divides by 5, 7 and 21 do not. And we're kind of out of options here. So there is no common factor. Next thing I would try is factoring by grouping. It is always worth trying, right? It saves you time. If it doesn't work out, we can just do factor theorem, but if it does work out, it is a lot shorter than factor theorem. So I am going to group together my first 2 terms and then my last 2 terms. The first 2 terms both divide by 3 and 5, and more importantly, 15. So I'm going to take out the largest common factor, which is 15. They both have an x, and the smallest exponent is a square. Okay, I would need to multiply 15x squared by another x to get 15x cubed. I would need to multiply 15x squared by 3 to get 45x squared. All right, the sign always stays from the middle here, so this is a minus. 7x and 21 both divide by the number 7. I would need to multiply negative 7 by I would need to multiply negative 7 by x to get negative 7x. And I would need to multiply negative 7 by positive 3 to get negative 21. And then on the other side, it is still just a 0. These two brackets are the same, which means factoring by grouping is going to work. So that means this is x plus 3 times 15x squared, take away 7. And then that still equals 0. Now, when we're solving by factoring, right, we're trying to find two things, right, a value for x that would make this equal 0. If I multiply two things together and we're getting an answer of 0, one of them has to be a 0. So either x plus 3 equals 0, or 15x squared, take away 7, equals 0. Now, I didn't talk about this. This looks sort of like a difference of squares. It has an x squared. There's two terms. They're being subtracted. But 15 and 7 are not perfect squares, so I didn't try to factor it as a difference of squares. I just left it. All right, so from here, x plus 3 equals 0. I'm going to subtract 3 from both sides to get x equals negative 3. This one here, 15x squared take away 7 equals 0. I'm going to add 7 to both sides. So I get 15x squared equals positive 7. And then I would divide by 15. So x squared is 7 divided by 15. Now I do like to check. It doesn't say anything in the question about using a decimal. But if it works out to be an exact decimal, meaning something I don't have to round, that's okay. Unfortunately, this is not an exact decimal. So I am going to leave it as 7 over 15. And then to cancel out a square, I would do the square root of both sides. Now, since this is an even numbered exponent, that means x could either be a positive answer or a negative answer. So I need to include the plus and minus. The square root of 7 is a decimal. The square root of 15 is a decimal. So I'm just going to leave it as the square root of 7 over 15. If the question had said that it was okay to round to 2 decimal places, I would actually work out what that is as a decimal, but it didn't. So I'm going to leave it as plus and minus square root of 7 over 15. So I am, because I have more than one answer, just going to finish off with a little therefore statement. I'm going to say therefore x equals negative 3. It equals positive square root of 7 over 15 and the negative square root of 7 over 15. And those are my 3 solutions. All right, I'll see you in some later videos to talk about solving by the quadratic formula.